Speaking of reliability, a podcast with good friends talking with you about reliability engineering topics. Welcome to Speaking of Reliability. This is Fred Schenkelberg.
And this is Enrico Belmonte.
Hey, Enrico. We were chatting just briefly before hitting record here, and I hope you get some cool weather here quick, because like you mentioned, it's not typical this time of year to be so hot over there. So
yeah, I'm waiting for the rain because my vegetables are suffering,
Oh, yeah.
Yeah.
Now that'll do it. Well, it's a good time to take the kids out for ice cream. I guess that's about all you can
do. Yeah, that's for sure.
All right. Well, hey, I got an email. We've been asking people for questions and comments and stuff, I think since episode 2. And I got a pretty good long email. Started off with a compliment and saying, every time I watch a webinar or read an article on a Sunday, this is a quote, I feel very lucky to be able to access them for free. Well, depends how much you pay for your internet connections and stuff like that. Thanks for providing such valuable content and being accessible. And this is, I think, our third email exchange. I see that you reply to virtually all comments, which is true. I don't reply to spam comments. I just delete them and mark them as spam. And he says, thanks for your investment of great amount of time and energy in making that all work, or paraphrasing the last bit. But he went on, he says he's working in a factory, lots of equipment, different industrial pieces all over the place. And he's trying to come up with a system model for a production line, is what I gathered. And he said the internal data that they have is very messy, if it exists at all. So getting time to failure data or time of repair type information in order to do a fit a curve to it or anything like that didn't seem like that's really a practical approach for him. So he said, he had a 4-step outline of what he wanted to do. He said, consider the reported MTBF as representative. And this is reported in a database of failure rates and MTBF values for industrial equipment. I think it's called OREDA, OREDA. And he says, the reported MTBF represents the item's useful life. And he had that in quotes. And that it's a constant failure rate. Okay. 2 was adopt a beta value typical for that item. And I'm thinking, like bearings would be a 2 to 3 beta. I know capacitors, big capacitor type items would be like a 7. But I'm not real sure about motors because there are all kinds of technologies and sizes and stuff. But some of that stuff's available. And then use the MTBF expression for the Weibull distribution with the gamma function. And
that becomes a little bit tricky. Yeah. Okay.
Yeah. And use that to compute the eta. So he's using the characteristic life. But it's a bit of a bit tricky math there, but I think you have to make some assumptions, but I think you could do it. Then use those beta and eta values in the calculations to for preventative replacement and sparing, stuff like that. And I like, So started with a constant failure rate and got a Weibull distribution out of it. And it's not unheard of to assume a beta value. Or if the beta value is to use something to deal with the eta to then get the distribution. What do they call it? A Bayesian Weibull approach or something like that. Waybays, I think they call it. But I'm trying to. So I responded, but I'm really curious what you think of this 4-step approach.
So I would say there are different layers here. So the first layer is so the person who is contacting you, is trying to apply probably for the first time design for reliability in his company. He acknowledges he has no data. There is probably no no reliability culture. There is, according to your maturity matrix that you published together with Carl, we are pretty much on the left, so on the low maturity, right?
Yeah, to some extent, I would say so, but
Yeah.
not a lot of info to go off of. But
yeah, but let's assume it's. But this is, I wouldn't say this is not judgment. It's like there's the starting point for a lot of companies. They are running the business for a long time, and they say now we want to optimize. I don't know, maintenance time, or we want to reduce all the metrics related to reliability in the company where a lot of equipments work are operating.
Right.
And and they try to apply any approach which is delivering some results. Okay, so he acknowledged he has bad data, so he said, okay, even with bad data, I can generate results. It's like you do not have a good toolbox, and you try to fix the house without having any tools. It's pretty hard, right?
Yeah.
It's pretty hard, but probably this is a typical condition for this kind of companies. They do not have time to, or they think they do not have time to build knowledge and to buy the right tools for the right equipment for moving forward with reliability. And is making up, or let's say stretching some concepts, merging them somehow, and getting to the results. And I think this is really, really dangerous. And what is for me is important. It's a core issue in these companies that anybody is going to check whether what is done is good or not. So, and this is typical.
Yeah, and it'll be years before you know whether you're accurate or way off or made major mistakes.
You hire a reliability engineer or a technician. You say, hey, I need reliability. He or she is passionate about reliability. It's trying to, but has no background and supply concepts, and you deliver a result. Whether the result is correct or probably it is not, doesn't matter. At the beginning, at least. Of course, then especially in this case, you will realize afterwards that your calculation they do not match the reality. But how many companies do use reliability not in the proper way, but nobody is checking it, and nobody is looking it after 10, 12 years or 8 years, what happens in the market, Well,
there's a trap there that I've seen a couple of companies do is they say, oh, we'll use this database instead of our own data because collecting our own data is going to take a while. Yeah. But once you do that and you have a number, you have a model, there's no reason to collect data anymore. So you won't ever check and you'll still be battling unwanted downtimes and other issues. Yeah. But it's really hard to check if you believe you don't even need to because you have this other approach.
Yeah, I think this is another important issue what you mentioned. Basically, if you rely on data from database, you cannot distinguish anymore between, for example, good equipment or bad equipment, right? Or a reliable equipment and not reliable equipment. Basically, if you cannot select between vendor A and vendor B if you use the same activation energy or whatever MTBF for both, because right. That's but you cannot distinguish at all because you take the data from bibliography. But I think, and now I'm trying to understand also the perspective of these colleagues who are working in this field for the first time. They try to somehow to rank, what are the best and worst equipments parts in the reliability chain, and say, okay, based on literature, I expect the pump is worse than whatever. another component,
like a conveyor belt motor or something. But
Yeah,
you could go ask the maintenance team saying, or the spares, which parts do you buy the most often? That's a
yeah.
really good clue as to where the heavy hitters are. And the operations manager probably could give you a list of 10 things that are failing and really shouldn't. I think a bit of walking around and asking people, would you get you a good, like an FMEA or RCM type approach is you prioritize what's most likely to fail. What's our history tell us? Even if it's not written down, I bet you that there's plenty of people in that facility that know just by experience.
Yeah, but I want, you are offering first a solution, that we are getting to the data now. But
Mm-hmm.
just a little bit provoking you on this topic, Fred. There are a lot of companies where so they are not aware of uh, doing this step.
That's
So
true.
first of all,
That's true. That's true.
yeah. So that for low maturity level company, I think. Uh, the first step is to be aware of what is reliability and what are the metrics and why you shouldn't apply MTBF and MTTF, and this is like the sort of basic knowledge you need to know for avoiding big mistakes.
Well, it's true, and I can understand how people fall into it. Is that when for example, way back in the dark ages before the internet was much bigger than a gopher hole, we used tools like gopher searches or gopher networks to find things. This before search. I went to the library and I
Yeah,
asked the librarian for books on reliability, and I learned all about the exponential distribution and a couple other things. And luckily, I found a book by Wayne Nelson on accelerated
yeah,
testing, which is what I needed to know about because of my particular task at the time. But MTBF was in the standard handbooks of the day, and they still are. It's all over the place. So
hmm
it's it's not it's easy to believe without much experience that that's what everybody uses. I got to learn how to use it. And it just reinforces itself. And I've talked to companies that create reliability software, and this one was a well-known, well-used software package. And the first thing they would provide is you can calculate MTBF. Here's your
yeah,
data, get an MTBF value. And I says, why do you hobble these people so that they take perfectly good time to failure data and you give them something that's really not very useful? And he
yeah,
goes, that's what they want. That's what they ask
yes,
for.
yeah,
That's the number
exactly.
one request. Like, okay. Yeah. So I get that. I understand that from starting from scratch, basically, and trying to do a good thing. I do think that this person is going to move their organization further because they're already engaging. They're on Ascendo looking up stuff. They're sending questions to me. They may be sending questions to the other authors and stuff. I think they'll progress on that awareness stage pretty quickly. And it's to their
Yeah.
credit because they're asking. They're saying, is this right? Am I doing this right? Is this a good approach or not?
I don't know if you agree with me now, but I think that reliability is discipline where you can cheat a lot. Yeah, and if
Yeah, I agree with that.
you know you know you if you present like an activity on reliability and you start assuming beta here and eta there, and you assume failure rate here, and then you assume you can do whatever you want. You can produce the results you want. And I think now I'm thinking about it, but when compared to a simulation engineer, or NVH, a noise vibration
Hmm.
hardness engineer, they they get the verification quite instantly. For example,
Hmm.
if you simulate the formation of a sealing ring, then you test it and you get you have leakage, so the simulation failed. It
Hmm.
takes like not a week to do that. Yeah, for an MDH engineer is the same. So if the noise hasn't disappeared, you didn't perform very well. For a reliability engineer, it's different.
Yeah, you got to wait 4 or 5 years sometimes or longer.
Yeah, you need to wait a long time, and therefore, if you do not have like sort of steering committee or people, really competent people that are investigating or questioning what you are doing, you probably say, hey, I'm stretching some concept, combining them and getting data from bibliography. I'm not I'm even don't disturb anybody in the company because I find the data in the book, but I still get to result,
Yeah, you
even
still get
if
a
it's
number.
wrong.
You can underline it twice and you're done. Yeah. It's there's a whole bunch of pieces in there, but I think this person's going to be all right if they're asking the questions. The one that obviously threw me for a loop is assuming that MTBF was the item's useful life, is the point till it starts to wear out. And I like, that's so fundamentally untrue that it's not. So I want to make that clear without getting on my soapbox. See, many of my other writings and everything else about why that's not true. But the issue is that there are other options than going to look it up in a book. So the advice I gave him in a nutshell was go talk to your maintenance team. Find out the big hitters, go to the vendors, go to the literature, find what you can about that. Bearings are very well documented, and every vendor has models for what they think their bearing grease combinations will last, and they have formulas for it, and they're willing to talk to you about it. Motors, a lot of them are very well characterized, and depending on your application and temperatures and loads and stuff like that, that may be all fine. But my primary advice is take a look for things that are the quicker wins so that you can improve reliability this week, which is very visible to the operations team. So if you're noticing that motors and bearings on motors and shafts are wearing out really fast, and your maintenance team probably knows about that, is why is that? Start asking questions. What causes that to fail quickly? And it might be alignment. And alignment can be solved pretty quickly by a little bit of due diligence and paying attention to it. But with each and every type of failure that's plaguing your maintenance team is dig into why does that occur? What can we do to prevent that? And it might be alignment. It might be balancing. It might be a proper lubrication using the right material. It might be just ask those questions and make sure the procedures and techniques used on your equipment is up to speed as best as possible. Because if you don't have good basics in your maintenance program for your facility, you're never going to get to wear out. It's going to be failing all kinds of ways long before it really should. So don't worry about modeling its 20-year expected lifetime when it's not installed correctly and it's lucky to survive 1 year.
Yeah, no, but I think, as you said, if you start with a question, "What is my MTBF?" You just you are losing basically. The question is how can I improve? I can solve a problem. I can improve reliability. What is the reason of failures? Start investigating damage mechanism and fixing. What are the low hanging fruits, and then getting data. I always say, the company do not have time to they cannot wait just 1 year before result. You cannot say, hey, I now, in order to give you an answer, I need this 10,000 hour testing on 100 samples, for one mechanism. You cannot approach reliability in a kinetic way. You're still an engineer. So,
but over time, I think if you get those quick wins in the low-hanging fruit, using that metaphor, it helps build credibility. You learn about failure mechanisms and how you can work with that knowledge to make improvements. And some things do take longer. They do. But it gives you getting started doing something that actually is visibly makes a difference, or, in the metrics and in the performance of your facility. It gives you time to start gathering data, to express to the whole team, this is why this stuff is important. And you may find a treasure trove somewhere in there that somebody in the organization has great details on some aspect of the system.
Yeah.
Use that as an example of why it's so important. But you got to get started with some wins. And you're exactly
Yeah.
right, Enrico. You can't say, oh, this is the way to do it, and it'll take us a year to see if it's right or even make a difference. Well, work on where the pain is now and
Yeah.
get some of those solved. Yeah, I agree with that.
Yeah, I mean, it's a twofold strategy. So you need to consequently and in a systematic way gather data. On the other part, you need to provide statements regarding reliability. So you can also make assumption. As engineer, you should name the assumption and do not forget about the assumption when you revise them afterwards.
Yeah, that's right.
Because an assumption might be summed up with another assumption, with another worst case assumption, and so on and so on. And after 10 years, you create some products with the assumption are so conservative that you do not know anymore why they are there. Yeah, and you cannot design anymore. You lose competitiveness now against competitors because all the assumptions are summing up. So yeah, and we should not also neglect that these people they generally are alone moving forward this topic, and that should not be neglected, because you can start chasing people for data, but it's a hard task.
Oh, I get it. It's a challenge. Yet I think it's worth doing. It's if you can show value of reliability activities, that it helps you improve uptime, or it helps limit the amount of downtime that you get. Then it's, well, that was great. What else can you do? And it starts building that capability within the organization.
Yeah. No. So I agree with you. I agree with you with that. I always underline the topic credibility. How can you cultivate your own credibility over time? But it's these people. I think this guy in particular. He did the right step, asking you to support. Openly. In a transparent way. Say, this is my approach, and you can say this is wrong. It's far better than say this is my approach and I suppose it's true, so I'm going to apply it.
That's right.
Yeah. So that's also this importance of the review culture, to get if you don't have competence inside, you get outside asking for people, knowledgeable people, and a chain of reliability is also helping a lot. Yeah.
There's a few people that are more than willing to help. But yeah, it's anyway, I'll have to follow up, because you've sparked a couple other ideas I should let them know about, and let them know this is coming up as an episode. But like we always say, we really appreciate a question. So if you're listening to this and just getting started, or even a long-term one, and questioning, the approaches you and your organization are taking, those are great topics. We've got a lot of experience across the hosts of the show, and we're more than happy to get you an answer and discuss it with you. And then we'll probably talk about it, hopefully protecting your identity enough so that you don't get embarrassed by it. But it's not something to be embarrassed by. Is ask the questions, right? It's very helpful. And so we'll try to help as much as we possibly can and get you on the right track. And but we got to hear from you. That's the real trick. So you can do that a couple of ways. Head over to accendoreliability.com/go/SOR. There's a couple of ways to get in touch with us. Enrico and I and the other hosts of the show are available through LinkedIn and our about pages on Accendo Reliability. So please do give us a little context, the background, what's your thought process and what you're asking about. And Enrico, one of the questions I don't like getting is a simple one sentence question. Hey, Fred, how many samples do I need?
Yep.
And that's it.
22?
There's no context, no idea what they're trying to do or anything.
Yeah, that's not the proper way to formulate question to you. Yeah, I agree with that. Yeah.
Okay. So anyway, hopefully it cools off for you this evening, Enrico, and you guys can enjoy some ice cream this weekend. And but stay cool, my friend, and we'll talk to you again soon.
Thank you very much. I appreciate it. Bye, Fred.
Bye-bye. Thanks for listening to Speaking of Reliability. We invite you to join the conversation. If you have a question or a topic that you think we should discuss in a future show, please let us know. You can find a comment box below the episode show notes, or just leave a note as part of a review on iTunes.